Welcome to the lecture series of power electronics. In this session, I am going to discuss the design of single-phase full-bridge inverter using MATLAB. In the lecture number 93, I have discussed the detailed operation of single-phase full-bridge inverter. That is just for your reference. You can go through the video first. Later, you can come back to the MATLAB design. So we have to follow the following algorithm. First of all, you have to define the parameter. Next is actually you have to generate the switching signal. We have four switches. So we have to produce the switching pattern, switching signal we have to produce. Then you need to calculate the output voltage. Ultimately, you have to plot the waveforms. These are the four steps which are involved in the MATLAB design. So moving on to the first step, that is called parameter definition. So input voltage you have to define. Then the required output frequency, that is 50 hertz, I require to design. Then time period, it is a reciprocal of frequency that also I have to design. Then the switching frequency of generating the pulse, I need to maintain 10 kilohertz. If even I can go for 100 kilohertz also, there is no problem. So this is 10 kilohertz. Then the time you can the time which create the time vector for the two cycle of the output waveform, that is equal to starting from zero, then we can mention the time period, then complete cycle 2t. 2t means see, look at this. This is one cycle. This is another cycle. So we have t. Okay. Next, we'll be going for another t. That means 2t. Okay. So we'll be completing, we are going to design it for two cycles. If you want, you can go for further also. This is only for the information, right? So these are the things which you are supposed to do at the beginning only, parameter definition. Thereafter, generate the switching signals. Okay. So the PWM you are supposed to generate. So the switching signal S1 I'll be generating in this fashion. The square of 2 pi f into t. Okay, generate a square pulse for the control signal S1. So remember that S1 and S2 are complementary each other. Therefore, I'll be writing S2 is equal to S1. You can see the third step. Similarly, S3 and S4 are set similarly. S1 and S2 also should be complemented each other. So two pairs you are supposed to generate. Next one is called output voltage computation. So here, so you need to use the formula output voltage is equal to the switching signal S1 into VDC. VDC is the input voltage. So it calculates the output voltage across the load, that is A and B. 2 points will be the, so across the voltage, okay, across the load voltage, we'll be getting VAB is equal to VDC into S1. The inverter outputs plus VDC, that will be done whenever S1 and S2 are on. Then minus VDC will be getting whenever S2 and S3 are on. Depends on how you are going to give the nomenclature. It depends on the nomenclature. We cannot say that it should be S1, S2. So however you are going to generate the nomenclature, accordingly we'll be getting the voltage. Now, plotting the waveforms. Here you need to use subplot. Okay, so you have to show the switching signals as well as the output voltage. So these are the simple algorithm which are concerning for the MATLAB design of single phase full bridge inverter. Now I just wanted to show you how I have done the programming in the MATLAB. So you can directly open the MATLAB by double clicking the MATLAB icon. Then you are supposed to go to the editor file. Okay. Now let us see how I am going to show you the. Okay, you can check I have opened already MATLAB and I have given the name of the file as PG1 inverter design, that you can see I have saved accordingly. So we are going to perform the MATLAB design of single phase full bridge inverter. Then first of all, you are supposed to define the parameters. So I have defined input voltage, then the output frequency. I require 50 hertz. Okay, because normal supply will be 50 hertz only, no? Then I need to define the time period, that is equal to 1 by frequency. Okay, 1 by frequency. Next, the switching frequency also I have defined because I have four switches available. Okay, that means 10,000 hertz. It is nothing but 10 kilohertz. Then I need to define how long I need to generate the pulses. I'll be considering only two cycles of output. The second step is actually generating the switching signal. So you can use the formula S1 is equal to square 2 pi f t. Okay, 2 pi f means omega, right? Omega, 2 pi f, omega t, square omega t. Then S2 and S1 are complementary each other. Similarly, S3 and S1 also complementary. Then S4 is equal to S1, switch S4. Next is calculation of the output voltage of inverter. You can use the formula VAB is equal to VDC into S1. Ultimately, you are supposed to plot the input voltage, then output voltage, and the corresponding waveforms. Okay, so figure to create the layout, I require figure. Then subplot 3 comma 1 comma 1. What does it mean? So actually we have three figures. So it is arranged in the form of three rows. Then first column, only one column will be available. Then one means the first figure. Correct, no? Three rows, one column, first figure. Then plot t comma VDC into 1 size t. This is initialization, right? Then you are going to provide the color, red color, then line width of 1.5. Then title you are supposed to provide DC input voltage, DC voltage, because first graph is input voltage. The next label you can give the time and Y label voltage. Then grid on. You will be getting the graphical appearance. The second diagram should be supposed to be like a switching signal. I need to plot the switching pulses because we are going to generate the switching pulses to turn on the MOSFET switches. Subplot 3 comma 1 comma 2. That means the three rows will be the first column, second figure. Then I need to plot. Okay, switch S1 I need to plot. Then S2, this is S2. Okay, now this is S3 and this is S4. Because it's a continuous function, so I'll be continuous signal, I need to use plot. If it is a discrete signal, I need to use stem. Then title I need to provide switching signal, X labeling and Y labeling. Apart from that, I'll be providing the grid as well. Okay. Now plotting the output waveforms. Okay. Subplot 3 comma 1 comma 3. So I'm focusing on the third diagram. The third graph must be output waveforms. So I need to plot. See what are the parameters, whichever things are there. I need to plot. Plot T comma VAB. Okay. T should be X axis. VAB should be at Y axis. Then K line width, everything you have to set. Then title you are supposed to provide X labeling, give the name for X axis, then Y labeling, grid on. So once it is done, what you can do is, let me run the program. So I have run the program. So you have to create add to path. Okay, provide add to path. So just wait for a while. So I have to wait until I get the waveforms because I require DC voltage, later switching pulses, ultimately the sinusoidal output voltage. These are the things which I require. So now I'll be showing you the waveforms. Yes, I have got the graph. You can check it up. All of you can listen here. So let me zoom it. Here it is very pretty clear that see, now this is our output. So the input voltage that is equal to 100 volt. We already given the parameters, right? DC input voltage with respect to time. Now switching pulses you can see. This is the way how the switching pulses are generated. S1. So you can see the S1. Okay, this is called S1. Then S2. We have S2. Then we have S3. Then we have S4. Like that, you can see the switching pulses, how the switching pulses will be applying. It's a square pulse basically. Okay. Now, what about the output voltage? See, output voltage will be having, see, look at this, positive half cycle, then negative half cycle. See, this is positive half cycle, negative half cycle, positive half cycle, negative half cycle. I just generated for 2 cycles. So that is the outcome. I hope you understood. So this is the way how to convert the DC voltage into AC voltage. So the shape is square waveform only. Okay, that's all. So this is regarding the inverter design. So now let me know if you have any queries. So I am happy to answer back. You can directly put a message in the comment box. I'll be reverting back. So if you require the code, you can request, you can send a mail. I can share the same code and you can practice it. So thank you very much for watching this video. Happy learning. Have a great day. Thank you.